Okay, so the big thing with factoring is that we are basically going to take a trinomial or something sometimes with three terms. When you do common factoring this first lesson, they can have more terms. And we're basically going to do the reverse of FOIL or expanding. We are going to rewrite it as a product. So usually we use X's. Sometimes there are P's and R's and Q's. It doesn't matter what the variable is. But what you want to do is write your answer as a product, not as an expanded, simplified form. Okay? So it's kind of opposite to what you've done before. So yesterday when we did FOIL, we did an extension or the next step of the distributive property, sometimes called double distribution. And we got an answer like this. Now, in this chapter, we're going to take this and rewrite it like that. You do need to remember the exponent laws. So we already talked about this one. If you have the same base, you add the exponents. If you divide, then you subtract. And when we do factoring, you're not going to get a negative exponent. So I know last year that was one of the things you had to do with exponents and then rewrite it as a fraction, but really you should get a positive, okay? So here these are numbers. Sometimes we're going to have letters like, again, X and Y, and then you just add the exponents when you are multiplying. And when you're dividing, you subtract. Okay, so we'll just review these again. So again, if you're an arrow drawer, that's fine. 2 times 4x is 8x. 2 times 7 is 14. When you have a negative, that affects the sign as well. So negative 5 times 6x is a negative 30x. Negative 5 times negative 9 is positive 45. So again, now you're doing 3x and 2x, so you multiply the numbers, and then when you multiply something that has a common base, you add the exponents. 3x times 5, you just have to multiply the numbers. When we do 4.2 and 4.3, we're going to look at trinomials, which are in standard form. Today, this section, when we do 4.1, when all we're doing is looking for the common factor, they can be whatever they want. Okay, so here we have 2s and 4s. You just have to follow the exponent laws. So this times this, 4 times 3, 12. X squared times x to the power of 4 is x to the power of 6. Try not to screw yourself up and do like 4 times 2 as well. Okay, so you multiply the numbers, but then the bases you add the exponents. And then 4x squared times 4x squared. So 4 times 4, 16. X squared times x squared is x to the power of 4. Okay, so factoring, we are going to write it as a product of whole numbers. Okay, so when we get to chapter 6, we'll look at what happens if you can't get nice numbers, what happens if you have decimals. We're going to use something called the quadratic formula, so it's not impossible. However, in this section, we want either a positive, they can be positive, they can be negative, but it has to be a whole number. 4, 2, 10, 20, whatever, okay? So what we're looking for is we want to break it down into the numbers that can't be divisible anymore. So when you talked about greatest common factor or lowest common multiple, stuff like that in elementary school, then we're not going to divide by 1. Okay, so those rules still apply. So 24, for example, can be written as 6 times 4. However, 6 and 4 are divisible by 2, right? You could write 24 as 12, 2 and 12. 2 can't be divisible by anything other than itself, but 12 can be 6 and 2. It can be 3 and 4, which can then be 2 and 2, right? So we're trying to get to the lowest common multiples. So when we write 24 as 2 times 2 times 2 times 3, then we call that fully factored. None of the factors can be divided any further. Again, we're not going to include 1. Okay, so those are considered prime numbers. So when you factor, you're going to express it as a product. And what does that mean? You're multiplying. So you do need to remember, we usually don't write multiplication symbols. We're going to use brackets that are beside each other, which means multiplying. When we do common factoring today, normally it'll look more like the distributive property you would have done in grade 9. So there could be a number out front of the bracket, there could be a number and a variable, there could just be variables. Okay, so no matter what we do, and you'll notice even in the later sections, it'll say you have to always check for a common factor first, and Ms. Tarantello loves that. Okay, so in grade 11, then when you have to do this again for tougher questions, then you'll want to make sure you always look for the common factor first. So if you don't remember what GCF is, it's greatest common factor. So number 1 says determine the largest number that goes evenly into each term. What does goes evenly in mean? In terms of math, what are we going to do? We're going to divide. And it has to be each term. So you can't just, if there are 3 terms in your expression, you can't divide 2 of them by the greatest common factor and not the third. That's not how it works. What you do to one thing, you do to them all, right? A very common rule in math. So you have to make sure that if there are variable or variables, they have to be present in all terms. So like a variable would be like x or xy, for example. Okay, so if you're going to say that xy is the greatest common factor, then there has to be an xy in each of the terms that you can divide. When you're trying to find the greatest common factor, look for the lowest value exponent. So if you have one that's like then even though this is 10 and this is 6, this is the lowest. So this determines the greatest common factor. Okay. So this question, all it wants us to do is find the greatest common factor. So what that means is we need to find a number that divides evenly into 4, 16, and 32. So what I recommend that you do first, the easiest way to do this is check and see if 4 works. Okay? So we're going to divide 4 by 4, 16 by 4, and 32 by 4. And check and see. What's 4 divided by 4? 1. 16 divided by 4 is 4. And 32 divided by 4 is 8. So is 4 a common factor? Yes. But you want to make sure it's the greatest. So then you check again. Can 1, 4, and 8 be divided by anything else the same? Not including 1? No. So then 4 is the greatest common factor. So now the next one, 3, 15, 75. I would like to try 3. But now we also have x, x squared, and x cubed. So x can be part of your greatest common factor. So then, since x here has the lowest exponent, I'm going to try that one. I don't have much room, so I'm going to just rewrite it over here. 3x divided by 3x. So you can think of this a few ways. If you like to think of things canceling out when they're exactly the same, you can do that. So 3x and 3x are exactly the same. When you divide anything by itself, what do you get? 1. Or you can do 3 divided by 3. That's 1. And when you divide, what do you do with the exponents? Subtract. What's 1 minus 1? 0. Okay? Anything to the power of 0? What's that? 1. Yes. Okay? So these also cancel out or go away. 15x squared divided by 3x. 15 divided by 3 is 5. X squared divided by x. So again, you're subtracting. You're left with 5x. If you are the kind of person who likes to cancel, you can do that too. Like this x cancels with one of these, and there's 1 left over. That's an option as well. Basically, all you're doing, when you're canceling, you're essentially subtracting. And then 75 divided by 75 cubed, x cubed divided by 3x. 75 divided by 3 is 25. And if you don't know that, then just put it in your calculator. And then again, now you have 3 minus 1, which is squared, or you cancel out 1 here, and 3 subtract 1 is 2, okay? So now we check. Can 1, 5x, and 25x squared be divided by anything else? No. So the greatest common factor is 3x. Okay, so 12, 15, and 21. You can't divide 15 and 21 by 12. So there has to be another number, hopefully, that is going to be our factor. So if you did not do a lot of practice with multiplication tables in elementary school, maybe last year you did a little bit but not enough or whatever, again, this reference sheet, so this one up here is one version of a multiplication table, and this one down here is more of like the traditional version, okay? So this can help you. You can look for, in the top one, if you look here, 12, 15, 21, all divisible by 3. Maybe your brain can see that it's divisible by 3. You could do trial and error with your calculator. We're going to have to do multiplication tables for we're going to do multiplying but multiplying whole numbers like this for every single type of factoring, okay? So if you didn't do a lot of practice with that, or that's an area where you struggle, then maybe you want to use this reference sheet as a starting point even, okay? So I'm going to divide by 3. But then I have to check the x. So this is x squared. This one's only x1, and this is x3. So all we can divide by is x. This is y1, y3, y3. So again, you can only use the lowest one. So I'm going to check over here. Divided by 3, 4. X squared divided by x is x. Y divided by y turns to 1. Go ahead. Are you ready? 15 divided by 3, 5. X divided by x, that turns to 1, or they cancel out. And then y3 minus y, you're left with y2. (21) divided by 3 is 7. X3 minus x, x2. Y3 minus y is y. Now you check. 4x, 5y squared, 7x squared, y squared. Can any of these be divided by the same thing? Nope. So our greatest common factor is 3x. Okay? So normally, there are questions that say, what is the greatest common factor? But normally, the question is going to ask you to factor. So they'll give you an equation like this, and you have to rewrite it as a product. So we did expanding or FOIL yesterday. Today we're going to factor. And when you do factoring, you can actually check using expanding or FOIL. So if the question says to check using FOIL, make sure you do that. Just like checking in the first unit, you'll get marks for it. If it doesn't say that, then you might not get marks for it, but it's a good way to check that you have the right answer. So no matter what kind of factoring we do, all through chapter 4, you can check your answer. Okay, so we are going to factor 4n minus 10. It does not matter that it's n's and not x's. That doesn't matter. So what you should do is check. Usually if we want to get rid of or have the greatest common factor, try to divide the number first. Does 10 divided by 4 evenly? No. And the easiest way to check that is just do it. 10 divided by 4. Okay? If you suck at multiplication tables, I don't care. Just make sure that you're not trying to guess. Just use your calculator. 10 divided by 4, even if you're using your phone, that'll work, right? So 10's not going to work. Another factor of 4 is 2. Right? 4 only has one factor. And then when you're trying to decide about the variable, there's no number. or there's no n with 10. So we can't divide by n because it's not common. So we're going to divide by 2. So now 2 is the greatest common factor. So when you factor, you're trying to write it as a product. So this time you take the greatest common factor, 2, and then in brackets we write what's left over. What's 4n divided by 2? 2n. What's negative 10 divided by 2? Negative 5. So this question doesn't specifically say what is the GCF, or greatest common factor, but you have to make sure that that's what you're factoring out or dividing by, okay? So it's helpful to write it as a division, and then that's going to be the greatest common factor, which you write out front of the brackets. We remember factoring means we want to write it as a product. So now we have 2, and then bracket 2n minus 5, whatever's left after you divide. You can check by expanding. Okay, so, or redistribute, right? So 2 times 2n is 4n. 2 times negative 5 is negative 10. Do you get this? Yes. This question, it doesn't say here to check, but you can always do that. Okay, so again, we don't have a y in our second term. It doesn't really matter. Most people, and eventually when we get to 4.2, 4.3, 4.4, we don't want a negative in our first term, so you might as well get used to it. So divide by negative 2. Okay? And if you're not good at this, just do it in your calculator. Negative 2 divided by negative 2 is 1. So you can write 1y, or just y, whatever you like better, okay? And then 4 divided by negative 2 is negative 2. Okay? If you left it as negative y plus 2, and only called your greatest common factor as 2, I wouldn't take marks off, but again, try to get used to that because eventually we don't want negatives in our first term. Okay, here we have 3x and 3. We're going to divide by 3. 3 divided by 3 is 1, so again, decide if you want to write x or 1x. Negative 3 divided by 3 is negative. And then remember, you're always trying to look, can I divide x and -1 by anything else? No. So that means I've got the greatest common factor. Okay, so always you should check at the end. These ones are pretty simple, but when we get to the last examples, you'll see that it can be a little bit more complicated. You could have more than 2 terms, you could have 3 or 4. Okay, so you could also have a common factor, greatest common factor, that has letters and no numbers. It can be numbers and no letters. It could be both. Okay, so this first one, that x term has 1 in front of it. There is no 3 or 6 or whatever. So now our greatest common factor is going to be x, right? X to the power of 1 is less than x to the power of 2. So you're looking for the lowest exponent. So x divided by x is not 0, it's 1, okay? 3x squared, divided by x. Can't do anything with the 3, or 3 divided by 1 stays as 3. And then whether you think of it as canceling or 2 minus 1 becomes 1. And again, you should not get a negative exponent, okay? So here now we have our greatest common factor is going to be y. Y divided by y, 4y divided by y leaves 4. So again, you could think of it like canceling out. Or 1 minus 1 is 0, which makes 1. And then y squared divided by y, so 2 minus 1 leaves y to the power of 1. Negative 4x and 3x squared. 4 and 3 do not divide nicely. So we'll get rid of our x term. Because again, this is an exponent of 1, that's lower than that, so all we can do is x. Yes. We're almost done here. Okay, so then these ones have a combination of both, okay? So we have 2 numbers here. The 3 divided by 3 is fine. Can 6 divide by 3 nicely? Yes, it can. It's 2. So, and we also have an x. So the numbers are good. And then for the variables, you look for the lowest. So this is x squared, that's x. So 3 divided by 3 is 1. X squared divided by x is 1. I'm just going to write it in. You don't have to. You could write it like this. 6 divided by 3 is 2. X divided by x, 1 minus 1 is 0. Okay, so 24 and 16. 16 does not go into 24 evenly, and there are many factors. So you could do 4. 24 divided by 6. 24 divided by 4 is 6. 16 divided by 4 is 4. So 6 and 4 can still be divided. So you're looking for a higher greatest common factor. So 24 divides by 8, so it is 16. So you want to make sure that you get the highest. And again, you can do trial and error with your calculator. You can take a look at the multiplication table. (24 divided by 8 is 3. M squared, there's nothing we can do with that because the 16 does not have an M. Okay, so again, this last one, 24 and 48. My brain tells me, oh, maybe 12 will go in there, so double check. 24 divided by 12 is 2. 48 divided by 12 is 4, so that'll work. And then we have y to the 4, y squared, y cubed. So what am I going to use? The lowest one. So which one's the lowest? y2. Okay, it's going to work out nicely. We don't want y to the negative 1 or anything like that. It has to be nice, whole numbers. Okay, so 12 divided by 12 is 1. Whether you write the 1 or not is fine. Y to the 4 divided by y to the 2 is y to the 2. 24 divided by 12 is 2. Y squared minus y squared gets you y0, which turns into 1. 48 divided by 12 is 4. Y cubed and y squared. 3 minus 2 is 1. Okay, so there are questions in the textbook. If it asks you, this textbook loves to say things like, describe the strategy you used. You don't need to do that, okay? Just factor. These questions at the beginning are finding just the greatest common factor, and then it gets you to do, it's sort of like our examples. And then, like I said, you can do this first factoring assignment. It's also more practice, and the answers for the solutions for this are already on D12. Yes, ma'am. Yes, and you can go that way. I do have a couple here. If somebody didn't get this, and those of you that didn't finish this, if you want to do it now. I don't know who this is. Ramsey, do you want yours? Do you want yours? Keith, do you want yours? Yes. Yes. Oh, I'm coming, Ty. At the end of the day. Oh, no. But I haven't updated your mark yet. And you're not coming back, right?